On the morning of June 4, 1942, a solitary Mitsubishi A6M20 cut through the fog above Alaska's Aleutian Islands, its engine laboring. Flight Petty Officer Tadayoshi Koga, 19 years old, flew with two fellow pilots from the carrier Ryujo on a mission returning from the Dutch harbor raid. The weather turned treacherous, visibility reduced to mere yards, and as he descended searching for a landing site, his aircraft's wheels caught the soft tundra of Akutan Island. The Zero flipped, snapping its propeller and breaking Koga's neck instantly, leaving the aircraft miraculously intact. For 5 weeks, the wreck lay undiscovered in the wind-swept isolation of the Aleutians until a PBY Catalina crew spotted the metallic glint beneath the cloud ceiling. When U.S. Navy recovery teams arrived, they realized instantly what lay before them: the first undamaged Zero ever captured. Its pale green fuselage, riddled only with minor bullet marks, represented a priceless opportunity to unlock Japan's aerial dominance. Carefully, engineers disassembled the fighter and shipped it to San Diego under armed guard, labeling crates as routine cargo to conceal their significance. Halfway through this unfolding miracle of intelligence and engineering, remember to like, share, and subscribe to uncover more stories that changed history's direction forever. When the aircraft reached the North Island Naval Air Station, it was reassembled meticulously under supervision of aviation experts from the Bureau of Aeronautics. Each component was documented, every rivet examined, every system evaluated for weaknesses. The captured Zero received a new American serial number, AAI-1, marking its transformation from enemy weapon into instrument of revelation. Mechanics remarked on its extraordinary craftsmanship, lightweight structure, and delicate control surfaces that made it agile yet fragile. By late summer, the Zero stood gleaming on the runway, its Japanese markings replaced by stars and bars of the U.S. Navy. Naval officers gathered quietly along the tarmac as test pilot Lieutenant Commander Eddie Sanders approached, aware that what he was about to fly could change the Pacific War. On September 20th, he climbed into the cockpit, adjusted the harness, and advanced the throttle, hearing the unfamiliar tone of a captured engine roaring beneath his hands. As the Zero lifted from the runway into the California sky, history tilted subtly toward advantage. The war's most dangerous secret had finally switched sides, and the path to dominance had begun in silence above the Aleutian fog. On September 20th, 1942, Lieutenant Commander Eddie Sanders taxied the fully restored Akutan Zero onto the sunlit tarmac at North Island, San Diego. The fighter, light as silk yet lethal as glass, trembled under its new life, an enemy reborn beneath American insignia. As Sanders advanced the throttle, the Sockeye engine screamed into motion, its 12-cylinder hum carrying the ghosts of Pacific skies where hundreds of Allied pilots had fallen. Observers watched in silence as the fighter lifted smoothly, climbing toward 10,000 feet, beginning a series of flights that would rewrite aerial warfare. From the moment the wheels left the ground, Sanders noticed astonishing agility at low speed but dangerous stiffness above 200 knots. Rolling sharply right, he felt the ailerons harden, a metallic resistance that froze the aircraft mid-turn, revealing the Zero's first fatal flaw. Diving to test acceleration, he discovered the Japanese engine's carburetor faltered under -G, choking power completely during inverted maneuvers. These discoveries, confirmed across 24 meticulously logged flights, gave the U.S. Navy what it had lacked since Pearl Harbor: technical truth against myth. Every recorded vibration, every abrupt stall, and every curve of response told engineers how to build a killer aircraft. During debriefings, Sanders described the experience as enlightening yet eerie, flying an enemy creation that mirrored perfection but concealed hidden fragility. Engineers noted the Zero's unprotected fuel tanks, absence of armor plating, and paper-thin fuselage designed for range rather than survivability. It was not merely a fighter, it was a philosophy of war prioritizing agility over endurance, belief over pragmatism. By dissecting it in flight, Sanders dismantled the illusion of Japanese invincibility built upon early victories across the Pacific. He returned daily, repeating high-speed dives, low-level turns, and climb tests, while Grumman engineers observed each motion from the ground with notebooks ready. Every discovery filtered directly to the F6F Hellcat design team, then refining their prototype. They added metal-covered control surfaces, improved hydraulic boosts, and installed fuel injection systems immune to negative G failure. Within weeks, the captured Zero had become a blueprint for dominance, its secrets embedded into America's next-generation carrier fighter. By the end of October, Sanders concluded his 24th flight, landing smoothly as officers rushed forward to debrief him beside the still-smoking exhaust. In that moment, the balance of the Pacific War quietly shifted. What began as wreckage on a frozen island had evolved into knowledge destined to define victory. The enemy's pride had become America's path to mastery, one test pilot's courage transforming captured steel into strategic supremacy beneath the Californian sun. In late October 1942, at Grumman's Bethpage facility on Long Island, engineers gathered around blueprints illuminated beneath the pale glow of drafting lamps. The data from Eddie Sanders's test flights had arrived by courier that morning, sealed in envelopes marked Top Secret, Naval Air Intelligence. Every figure, every chart, every flight note represented revelation, an enemy's secrets distilled into pure engineering advantage. Chief designer Roy Grumman and his team pored over each page, recognizing at once that these results could change everything about carrier aviation. The Zero's weaknesses were now measurable facts, not distant rumors carried from desperate pilots over Midway. Its sluggish roll rate above 200 knots exposed its vulnerability to high-speed boom and zoom attacks. Its float carburetor failure under negative G confirmed a perfect escape maneuver that could save American lives. Most crucially, its light frame, built for range and agility, offered no protection from heavy machine gun fire. These vulnerabilities became the foundation of a fighter meant not just to compete, but to annihilate its rival in every measurable aspect of performance and survivability. At Grumman, every engineer understood the challenge ahead. The new F6F Hellcat prototype had to combine ruggedness, power, and simplicity, qualities that reflected American industrial philosophy. The Pratt & Whitney R2800 double WASP engine promised nearly 2,000 horsepower, enough to lift armor plating, self-sealing fuel tanks, and 6 Browning 50 caliber guns without sacrificing range or climb rate. The design team decided to thicken the wing spars, reinforce the fuselage, and create a wide landing gear that could endure violent carrier recoveries in storm conditions. It was a fighter built not for finesse, but for domination. Production accelerated as Grumman's assembly lines shifted into wartime rhythm, with welders, riveters, and draftsmen working around the clock. Blueprints changed overnight as test data continued to refine aerodynamic control systems. Hydraulic-boosted ailerons, inspired directly by the captured Zero's stiffness issue, became a revolutionary feature. Fuel injection replaced carburetors entirely, erasing the negative G weakness that crippled Japanese fighters during dogfights. For the first time in the Pacific, American aircraft would own both the vertical and horizontal planes of combat simultaneously. As final prototypes roared across Long Island skies in December 1942, observers reported a sensation rarely felt during that dark year: confidence. The F6F Hellcat was heavier, stronger, and deadlier, yet astonishingly stable even at extreme speeds. Engineers watched its test flights knowing they had turned enemy knowledge into mechanical vengeance. What the Akutan Zero revealed in weakness, the Hellcat transformed into strength, a symbol of America's capacity to learn, adapt, and outbuild its enemies with relentless precision and industrial might. On November 20, 1943, the sun rose over the Gilbert Islands as Task Force 53 advanced toward Tarawa Atoll under blazing tropical skies. The sea shimmered with steel and purpose as newly deployed F6F Hellcats launched from carriers USS Essex and USS Bunker Hill, their wings glinting with salt and sunlight. Below, waves of landing craft churned toward Bedio Island, where entrenched Japanese defenders waited with coastal guns zeroed in on the reef. Above this chaos, American naval aviation was about to prove the true worth of intelligence, engineering, and sacrifice combined. The first Hellcat squadrons, led by experienced pilots who had studied Sanders's test data, engaged incoming Mitsubishi Zeros at 8:15 a.m. near Tarawa's northern reef. What followed was unlike any air battle fought before in the Pacific. The Zero's traditional turning dogfight proved suicidal against the Hellcat's new energy tactics, which exploited superior dive speed, armor endurance, and firepower. Every roll, every climb, every disengagement executed at high velocity mirrored the lessons derived from that captured Akutan aircraft a year earlier. Within 20 minutes, 30 Zeros fell flaming into the ocean, while only a single F6F failed to return. As the battle expanded across the lagoon, carrier decks coordinated relentless strikes against Japanese positions. Hellcats swept ahead of dive bombers and torpedo squadrons, clearing the sky of resistance before TBF Avengers and SBD Dauntlesses descended upon the island's strongholds. Marine ground forces radioed that enemy air cover had collapsed entirely within hours, something never before achieved in earlier island invasions. The Hellcat had become more than an aircraft. It was the embodiment of American industrial learning applied through lethal efficiency. German and Japanese observers alike later studied the Tarawa engagements with disbelief. Reports noted the Hellcat's ability to sustain direct cannon hits and still return to its carrier decks. Enemy pilots described their frustration as the F6F outclimbed them at high speed and withstood maneuvers that would tear the fragile Zero apart. By sunset, the Pacific Fleet owned the skies absolutely, its victory confirmed by cold mathematics. 30 Zeros destroyed, 1 Hellcat lost. Tarawa's skies marked not just an operational success, but a psychological turning point. What once seemed divine Japanese invincibility now met its engineered equal. In every contrail stretching over the Gilbert horizon, the consequences of Akutan's captured Zero could be seen, proof that knowledge, not mysticism, now defined mastery of the air. By early 1944, the Pacific skies belonged to the Hellcat. From the Marshalls to the Carolines, its growling engines echoed across the endless ocean. What began as cautious confidence after Tarawa had evolved into calculated dominance, a methodical campaign of air control that turned Japan's outer defensive perimeter into a graveyard of aircraft and ambition. Every mission flown, every carrier sortie launched, drew directly from the engineering revelations of Akutan Island, where one fallen Zero had unknowingly betrayed an empire's aerial secrets. Fleet carriers USS Yorktown, USS Enterprise, and USS Lexington deployed full complements of Hellcats under the newly formed Fast Carrier Task Force. Pilots now trained to strike first, disengage swiftly, and conserve energy through disciplined vertical tactics. Gone were the turning duels that once favored Japanese agility. Instead, the Hellcat doctrine emphasized altitude advantage, coordinated wing pairs, and maximum burst fire at convergence distance. Japanese formations that attempted interception were annihilated in minutes, their outdated tactics collapsing under the precision of American coordination and overwhelming industrial supply. The sheer volume of replacement parts, engines, and ammunition reflected something far deeper than tactical superiority. It revealed strategic inevitability. American production lines were now constructing 400 Hellcats per month, an industrial miracle that even German observers documented with astonishment. At the same time, Japan's fighter assembly plants struggled to produce a fraction of that output, while suffering from aluminum shortages and bombing disruptions. By mid-1944, every carrier strike group entering combat knew that replacement aircraft already waited crated and ready on distant Pacific docks. The age of attritional anxiety had ended for the U.S. Navy. Hellcat pilots developed confidence that bordered on audacity. They flew deep escort missions for Avengers and Corsairs, scouted Japanese convoys near Truk Lagoon, and performed daring low-level attacks against enemy airfields. Combat reports documented engagements where squadrons of 12 Hellcats destroyed 30 or more Japanese aircraft without losing a single pilot. Such outcomes seemed unbelievable only 2 years earlier, when Wildcats had fought desperately just to survive. These conquests extended far beyond military calculation. They reshaped the morale and identity of American carrier aviation itself. The lessons from Eddie Sanders's test flights became unspoken doctrine. Study the enemy, exploit his limits, and transform weakness into strategy. Each flight over the Pacific reaffirmed this truth. The Hellcat wasn't simply winning the war in the air. It was rewriting the entire logic of aerial combat through intelligence, engineering, and relentless industrial purpose, setting the stage for the decisive battles that would soon determine the Pacific's fate. On the morning of June 19, 1944, as Task Force 58 advanced toward the Marianas, the Pacific sky shimmered with the vapor trails of destiny. The American invasion of Saipan had drawn Japan's remaining carrier fleet into battle, a final desperate gamble to halt the advancing tide. By dawn, over 400 Japanese aircraft were launching from carriers Shokaku, Zuikaku, and Taiho, veteran names now facing extinction. Waiting for them high above the fleet were nearly 500 F6F Hellcats, engines rumbling like an approaching storm. The greatest aerial duel of the Pacific War was about to begin. Radar pickets aboard destroyers detected incoming waves at 10 a.m., giving Hellcat pilots crucial minutes to climb into position. The Japanese believed surprise was still possible, unaware that American technology and discipline had erased that advantage months earlier. When the first enemy formation appeared against the blinding sun, carrier commanders issued a simple, confident order: get them all. What followed would become known forever as the Great Marianas Turkey Shoot, a slaughter so lopsided that even seasoned combat veterans described it as surreal. Within 3 hours, Japanese naval aviation ceased to exist as an organized fighting force. Hellcat pilots executed Sanders's energy tactics with mechanical precision. Dives initiated at superior altitude, firing bursts from 6 Browning guns before rolling away to safety. Japanese Zeros attempted their classic turning duels, but each maneuver exposed them to the Hellcat's unstoppable speed and firepower. Pilots described the radio chatter as eerily calm, altitude calls, formation spacing, and kill confirmations delivered with clinical detachment. The air filled with falling debris and burning wings, scattering across the blue expanse like fragments of a dying empire. Amid the chaos, carrier operations maintained flawless coordination. Deck crews rearmed and refueled aircraft in under 20 minutes, launching continuous fighter patrols that sealed Japan's fate. By dusk, the numbers defied comprehension. Over 300 enemy aircraft destroyed for the loss of only 29 Hellcats. It was industrial warfare distilled into the sky. Training, production, and technology converging into absolute dominance. The remaining Japanese carriers fled west, leaving behind empty flight decks and demoralized survivors floating amid wreckage. For the first time, Allied commanders understood that Japan's air arm would never recover. Replacement pilots lacked training hours, replacement aircraft lacked engines, and replacement hope no longer existed. The Akutan Zero's legacy had reached its brutal climax here, above the Marianas, where the empire that once believed spirit could overcome steel finally discovered that steel, when forged by knowledge and industry, was unbreakable. By late 1944, the F6F Hellcat reigned supreme across the Pacific, its broad wings casting shadows over every Japanese-held island and convoy. What had begun as a desperate contest for aerial survival had become a systematic dismantling of the enemy's ability to fight. The Great Marianas victory had not merely crippled Japan's carrier aviation, it had erased its offensive power entirely. Every subsequent battle now unfolded under the same undeniable equation. Wherever the Hellcat appeared, Japanese resistance dissolved within hours. The psychological shift was total, and both sides felt it with equal weight. Carrier strike groups advanced relentlessly toward the Philippines, striking at Formosa, Okinawa, and the Ryukyus in an unbroken chain of assaults. Each operation followed a rhythm honed through experience. Hellcats cleared the skies, Avengers bombed convoys, and Corsairs strafed airfields into silence. Japanese pilots, many barely trained teenagers, entered combat with fewer than 100 flight hours and outdated tactics their instructors had learned before the war. Against them flew veterans whose survival rates soared past every expectation, their machines crafted from the lessons of Akutan and perfected through industrial consistency unmatched anywhere on Earth. At the Bureau of Aeronautics, production figures painted the war's true dimensions. By December 1944, over 12,000 Hellcats had rolled from Grumman's Long Island assembly lines, delivered to carriers faster than combat losses could reduce inventory. Spare parts arrived pre-packaged in numbered crates, engines swapped within hours on floating maintenance barges. No fighter in history had been supported by such depth of logistics. Japan's surviving intelligence officers recognized this imbalance with growing despair, realizing the conflict had evolved beyond bravery or tradition. It had become a contest of factories, mathematics, and relentless mechanical repetition. Pilots returning from sorties described scenes of near-total absence, enemy skies empty, interceptors vanishing before radar could even report contact. Each victory deepened a paradoxical sense of detachment among American squadrons. Triumph had grown so certain that combat began to feel procedural. War diaries from carrier decks recorded the eerie silence following engagements, as if the thrill of danger had been replaced by industrial routine. The F6F had transformed air war into assembly line precision, a reflection of a nation that could adapt faster, learn deeper, and build harder than any adversary in history. From Palau to Iwo Jima, the Hellcat's dominance became an airborne monument to technological intelligence and manufacturing supremacy. The Empire of Japan still held territory, but its air power, once a symbol of terror, was already gone, replaced by contrails of inevitability stretching endlessly across Pacific horizons. By early 1945, American carrier groups now operated within striking distance of the Japanese homeland, launching daily raids against industrial cities and military installations. The F6F Hellcat, once conceived from captured enemy insight, now soared above Tokyo, Osaka, and Yokohama with the authority of an empire reversed. Japan's surviving aircraft, obsolete Ki-43 Oscars, Ki-84 Franks, and aging Zeros rose to meet them in dwindling numbers, their pilots driven by desperation rather than doctrine. Each sortie represented not defense but defiance, a futile attempt to contest skies already owned by overwhelming industrial logic. As the Battle of Iwo Jima raged below, Hellcats maintained continuous patrols above the volcanic island, providing close air support for Marines under relentless fire. The coordination between naval, air, and ground forces demonstrated a mastery of combined operations previously unimaginable in 1942. When Japanese airfields on Kyushu attempted kamikaze operations against the invasion fleet, Hellcat interceptors responded with ruthless efficiency, shooting down attackers before they could breach the outer defensive screen. Even amid suicide tactics, the imbalance was absolute. America's technological depth ensured that every lost aircraft was instantly replaced, while Japan's factories lay in ruins beneath the same bombers those Hellcats escorted. In March, Operation Meeting House brought destruction beyond imagination as carrier-based Hellcats joined B-29 raids over Tokyo. Pilots described the city as a glowing vortex of fire visible from 60 miles away, its once mighty industrial belt consumed in a single night. The F6F's role extended beyond combat. It had become the ever-present guardian of bombers, ensuring the annihilation of Japan's last production capacity. No longer was the Hellcat merely an interceptor. It was now a symbol of industrial supremacy, weaponized into unrelenting precision. Naval intelligence units recorded the despair within Japanese command communications intercepted during these months. Reports revealed the shrinking pool of trained aviators, the shortage of high-octane fuel, and the collapse of aircraft component distribution. The Empire's most advanced designs, Shidenkai and Raiden, barely reached squadrons before assembly lines were incinerated. In contrast, Grumman's engineers continued refining field modifications, integrating radar pods, improved gun sights, and night fighter adaptations, even as victory approached. Such adaptability epitomized America's relentless evolution under fire. By August 1945, Hellcat patrols escorted bombers over Hiroshima and Nagasaki, unaware they were witnessing the final expression of technological dominance. The weapon that ended the war was atomic, yet the path to that moment had been carved by the same philosophy, the belief that knowledge, not zeal, determines survival. Above a broken empire, the Hellcat's shadow stretched across the dawn of a new world, where warfare had forever changed its meaning. When Japan formally surrendered aboard the USS Missouri on September 2, 1945, the Pacific lay silent except for the rhythmic hum of carrier engines. The F6F Hellcat squadrons that once roared into combat now circled peacefully overhead, guardians of a sky they had conquered completely. For the men who flew them, the war's end carried not triumph alone, but a strange melancholy, a realization that victory had come through the mechanization of courage. What began with a crashed Zero on Akutan Island had culminated in an era where machines, not mysticism, defined destiny. American engineers returned to their factories, studying combat reports to refine post-war fighter concepts. Every note from Grumman's wartime design logs informed the transition toward jet propulsion and advanced aerodynamics. The lessons were enduring. Understand your enemy's strengths, exploit his limits, and let data guide evolution. The Bureau of Aeronautics established the Akutan Protocol, a classified guideline urging future designers to analyze captured technology as a cornerstone of innovation. Thus, from a single recovered aircraft, a doctrine of perpetual improvement was born, one that would echo through Cold War aviation for decades. For Japan, the transformation was equally profound. Post-war engineers like Jiro Horikoshi, who once designed the Zero, devoted themselves to peaceful aeronautical research under Allied oversight. The tragedy of lost generations gave rise to new industries built on reconstruction rather than conquest. Pilots who survived the conflict spoke of their respect for the Hellcat's engineering, acknowledging it as a weapon of precision rather than cruelty. Through interviews and memoirs, they admitted that the Zero's beauty had masked fragility, while the Hellcat's brute strength embodied the future. The U.S. Navy redefined its role in global defense through lessons forged in Pacific skies. Carrier aviation became the backbone of post-war deterrence, and every design, from the Panther to the Phantom, carried the genetic imprint of the Hellcat's philosophy. The industrial mobilization that produced thousands of these fighters had reshaped the American economy, proving that democracy could outproduce tyranny without abandoning humanity. Yet beneath the statistics and blueprints lingered quieter truths. Pilots who once chased victory through burning clouds now remembered faces, not numbers. Friends lost, adversaries vanished, skies scarred by glory. In the stillness after surrender, the Hellcat rested as more than a machine of war. It stood as testament to the dual nature of progress, its brilliance born from destruction, its legacy balanced between innovation and remembrance, reminding future generations that mastery without morality invites repetition of the same terrible perfection. In the decades following World War II, the F6F Hellcat became more than a machine. It became a monument to knowledge transformed into survival. Its metallic silhouette stood preserved in museums from Pensacola to Pearl Harbor, silent yet eloquent in its testimony to an age when intellect conquered illusion. Engineers, historians, and aviators studied its form, tracing rivet lines and control surfaces as if reading scripture carved in aluminum. Every component told a story of adaptation, from hydraulic ailerons shaped by Akutan's revelations, to the engine that roared with indomitable endurance across 1,000 Pacific horizons. The numbers endured: 5,163 aerial victories, a 19-to-1 kill ratio, and a generation of pilots who mastered war through discipline rather than desperation. Yet beneath those statistics lay something deeper. The embodiment of a civilization that chose to fight with reason rather than ritual. Where once the Zero symbolized elegance of design and purity of spirit, the Hellcat represented evolution's harder truth, that survival demands pragmatism, and victory belongs to those who learn faster than they believe. Each museum exhibit, each restored aircraft gleaming under hangar lights, carried that silent dialogue between faith in willpower and respect for empirical understanding. For Japan, the legacy of defeat became a foundation for renewal. Former Zero engineers contributed to rebuilding a nation that would soon lead the world in precision manufacturing and aviation technology. The humility born from loss turned into a cultural strength, an acknowledgement that progress must follow truth, not myth. The Akutan Zero, once a symbol of tragedy, became an educational relic, reminding both sides that knowledge shared in peace achieves more than intelligence gathered through war. Modern aviators still feel echoes of that legacy each time they step onto a carrier deck or climb into a cockpit surrounded by technology descended from 1942. The systems that safeguard pilots today, radar integration, reinforced structures, energy-efficient propulsion, trace their ancestry back to lessons learned from one captured aircraft and one determined test pilot. History had proven that understanding an adversary's weakness was not humiliation, but evolution. As decades passed, the Hellcat's thunder faded into memory, yet its meaning deepened. It was no longer just a story about industrial triumph or aerial dominance. It became a reflection on humanity's paradox, the capacity to create destruction through intellect, and then rebuild peace through the same brilliance. Above every ocean it once patrolled, the legacy of that transformation still drifts unseen, eternal as the wind.